third maximum number. Given an integer array names, return the third distinct maximum number in this array. If the third maximum does not exist, return the maximum number. When we look at this example, there is three numbers, 3, 2, 1. First largest or first maximum is 3, second maximum is 2, third maximum is 1, so we need to return 1. There is no third maximum, so we need to return the maximum number. It is 2. Here, because it is in third distance maximum, so here we need to return 1. We need to sort in order of n. Normally we will remove the duplicates and then we can sort, and then we will sort in descending order, right? And then we will get the sorted distant integer numbers, right? And then I will take the third place, and then I can get that result, but it's gonna be order of n log n because I will have to sort the array after I remove the duplicates, right? So I will do I will solve this problem this time by using sorted set. That means like it is when we use the hash search, we were not allowed to save the duplicates, right? But this one, the sorted set, is we are saving the integer, but whenever we saved according to the way we want, if we want it as any or as any, it was sorted already. The sorted set will do the sorting for us, so we don't have to sort after we save every integers to this sorted set. Okay, so let's do this one. For the first time, I need to create a sorted set variable, a sorted set, yes, variable, right? Set integer, and then when we save like this, the default is as any order, but for now I would like to sort the maximum is the first, right? So for example, for the first time we have like this 1 2 3 4 5, right? And then the maximum is 5 4 3 2 1, right? So I need to sort in descending order, so I need to pass compare as a parameter in this constructor. Okay, so compare, yes, right? Compare integer, and then I will create, for example, a comma b according to a comma b dot compare compare to, and then I will compare with a. So we got the descending compare, and then we pass as a constructor when we create sorted sets, when we instantiate that. Okay, so then after we got the sorted set, after we instantiate the sorted set variable, and then I will loop every integer in our input integer arrays, and then I will add to our sorted set. So the sorted set will save our integers by sorting. When we are adding, it will take care of the sorting, right? So we already got this sequence. So okay, so we will return, right? We will return sorted set dot count. If the sorted count greater than 2, that means if we have that maximum number, we will take that element at 2, right? Because we start from 0. Else sorted set dot at 0, we will take the first maximum number, right? So it is saying return maximum number. That's why we will take at the 0 index, right? Okay, let's see. Okay, so I'm gonna submit this one to see what will happen. Okay, this is order of n, right, to find the third maximum number, but just the time complexity is order of n, right? But the memory is also the order of n, right? Because we have to save every integers from the inputs array, right? So if we want to reduce the memory complexity, and then we can also do the another way by creating just a variable, 3 variables. Okay, let's try that one too. So the integers numbers can be anything, right? From the very smallest integer to the largest integer number, right? So we cannot assume, for example, because I need to create 3 variables, right? So I cannot assume the smallest gonna be the smallest integer or smallest integer. I cannot assume that because the input can also be the smallest. So I will create the long and then int 64 dot min value. So it will not have problems with the input minimum integer numbers, right? Okay. Second is gonna be the same, 64 dot min values. Okay, I'm gonna see the lines of code. Okay, third is gonna be the same, right? Okay, min value. I'm sorry. Okay, so we get first, second, third variables, and then I will loop I equals 0, I less than numbers dot length dot length I plus plus, right? And then we will compare, right? If numbers I greater than first, that means it is bigger than our maximum value, so we need to change everything, right? So for the first time we need to change the third with the second maximum. Second maximum is gonna be with our first maximum. Our first maximum is gonna be the new inserted value from the input numbers. Okay, right? Else if there is another case, if numbers I greater than second, right? And I'm sorry and numbers I less than first, at the time we need to change our third with our second, and then second with our numbers dot I, right? Okay, else if it is not numbers I greater than third and numbers I less than second, so we need to change only our third value, right, with our input can be integer. Okay, then we finish right, and then we will get first, second, third, right? Okay, so if third not equal this one, our instantiate value, if it is not equal, that means we got third maximum number, so we need to return third, right? But it is a long value, but we need to cast to integer, right? Else if it is not, we need to return our first, right? Okay, let's try this one. So we need only 3 value. Oh, sorry, I forgot semicolon. So we need to create 3 variables, right? And then this one is the order of n. Time complexity is gonna be order of n. Then space complexity or memory complexity is just order of 1, right? So we can solve any way we want. This is very short and clear, but if it is thinking about the space complexity, the second way is better. Okay, so that's it. Thank you so much.